when we study atomic structure, it has two parts. That is configuration of nucleons, nucleons inside the nucleus, and electronic configuration. First, configuration of nucleons inside the nucleus. What configuration of nucleons? What is mean by nucleons? Nucleons means the constituent of nucleus. That is proton, neutron, meson, etc. And electronic configuration means how electrons are arranged around the nucleus. But in chemistry, we concentrate on electronic configuration, because electronic configuration says the chemical behavior of any element. When we study chemistry, it's all about chemical behavior of matter. So we are mainly concentrate on the electronic configuration of atom. All the chemical behavior of atoms largely depends on electronic configuration. So in chemistry we read only electronic configuration of atom. We don't bother about the configuration of nucleus. So the primitive theory, atomic theory, was a Dalton theory, and Dalton theory was proposed in around 1800, and Dalton theory is proposed at 1803, and the proposal are very simple, but it is very useful for even for modern chemistry. Let's see what is his proposal. all the matter of the universe composed of very small particle called atom. All the matter, whatever we see, all the matter is composed of ultimately by atoms, and it may be different type of atoms, but all the matter ultimately produced by collection of atoms. And the second point is atoms are indestructible. That is, we cannot divide it or subdivide the atoms in 2, 3 or more parts. That is, they cannot subdivided, created or destroyed. And the third point is atoms of same element are similar to one another and equal in weight. It means if we collect a sodium atom from moon, suppose, and collect a sodium atom from earth, the sodium atom are same each and every aspect. The fourth point is atom of different element have different properties and different in weight. And the last point, which is very, very important, the chemical combination of result from the union of atoms in simple numerical proportion. That is, if we take an example, suppose oxygen react with hydrogen to produce water, and their ratio of atom is simple. That is, maybe here for water it is hydrogen is to oxygen is 2:1, H2O, that is hydrogen is to oxygen equals to 2:1. It may be 2:3 for different compound. It may be 3:4. It may be 1:1, but it does not 1.5:1 or 2.25:1.75. It does not a fraction quantity. It is this law is obey 99.99% cases. Now, these all proposal is supported by different hypotheses and different experimental fact. Let's see what is the different hypothesis and different experimental fact to support the Dalton's atomic model. The first one is the first one is Gay-Lussac law of combination. What is this? It's a statement: at constant temperature and pressure, gases are combined in simple ratio of volume. That is, if we take an example, suppose the popular example is this reaction is known as Haber process. And if we take hydrogen and nitrogen at constant temperature and pressure, the ratio is hydrogen is to nitrogen into is to NH3 equals to 3 is to 1 is to 2. This is a simple numerical ratio. This hypothesis is supported by this experimental fact. And next hypothesis, we all know Avogadro hypothesis. At constant temperature and pressure, equal volume of gases contains equal number of molecules. And let's see how this hypothesis and combined with experimental fact support the Dalton atomic theory. More specifically, the point number 5. Let's see the experimental outcome. Suppose we take hydrogen and iodine and they react to produce hydrogen iodide. If we take 1 volume of hydrogen and 1 volume of iodine, it produced 2 volume of HI, which is supported by Gay-Lussac law. And by the use of Avogadro hypothesis, if 1 volume of hydrogen contain n molecule of hydrogen, then 1 volume of iodine also contains n molecule of I2, and produced 2n molecule of HI. Now, if we divide it by n, we see that 1 molecule of H2 and 1 molecule of I2 produced 2 molecule of HI. And if we divide it by 2, we see that half molecule of H2 and half molecule of I2 produced 1 molecule of HI. And we see to production of molecule, we do not any necessity to break atom. This support the Dalton's atomic theory that atoms are indestructible and they are combined to produce a molecule with simple numerical manner. Now let's see how different experimental fact is contrary to Dalton's idea. The first one is passes of electricity through glass at very low pressure. Process of electricity at very low pressure. And here we need some little explanation. Here is my setup. here is negative end, here is positive end, and the area is filled with some gas. The area is filled with some gas. And if we applied very high voltage, we see that the electricity is passed. And if we consider that element is made of atom, then how can electricity is passed in the vacuum? Something is come from atoms which passes which help to pass electricity through the gas. So we can conclude that the atom may be subdivided. This is the idea. And later on, this is the simple setup of cathode ray experiment. We can see later. And subsequently, after discovery of electron, then proton, and different other subatomic particles have been invented. Now, go to the next point: discovery of radioactivity. Discovery of radioactivity in 1895 showed that some atom may be unstable. We know the example of uranium. You all know uranium. Uranium spontaneously disintegrate and produced different atom. So they disintegrate spontaneously with creation of other new atoms. So atom may be destroyed and it may be converted to to other element. And last one is discovery of isotope. Proves that the same element may not be identical in mass. If we take the simple example of hydrogen, we see that hydrogen has three isotopes: H11, H12, and H13. They have different in mass. They have different, but they all are hydrogen. They have same chemical properties. So the same element, the atom of same element has different mass.